Hostel Room Allocation System. Team members are me, Bindu C. Patil, Kavya Sia, Kumar Mopagar, and Prajwal MP. First slide will be explained by Prajwal MP.
Introduction. In educational institutions, hostels play a crucial role in providing accommodation for students. However, manually allocating hostel rooms can be time consuming, inefficient, and prone to errors. A well designed hostel room allocation system aims to automate and streamline this process, ensuring fair and efficient room distribution based on predefined criteria. Motivation. Many universities and colleges face challenges in managing hostel accommodation due to manual allocation issues, lack of transparency, space utilization problem, difficulty in tracking records. A digital system can resolve these problems by providing an automated efficiency and user-friendly solution for hostel room allocation. Objective. The main objective of this project is to develop a hostel room allocation system that automates the room allocation process, maintain a centralized database, ensuring transparency, optimizes space utilization, provides easy accessibility. Importance of projects. A hostel rooms allocation system brings us several benefits, reduces administrative workload, improve fairness and efficiency, enhance students' satisfaction, facilities better record management, scalability. Problem statement. Managing hostel room allocation manual in educational institution is inefficient and prone to errors. The traditional method often lead to delay, unfair allocation, mismanagement of records, and improper space utilization. Without an automated system, administration face challenges in handling student performance, updating room availability, and ensuring transparency in the allocation process. Key issues: time consuming manual process, lack of transparency, inefficient record keeping, poor space utilization, difficulty in handling preference, administrative overload. An automated hostel room allocation system can solve these issues by providing a structured, transparent, and efficiency allocated process. Next slide will be explained by Bindu.
Hi, myself Bindu. Today I am going to explain about system design and architecture. This part outlines the architecture of a hostel room allocation system. It follows a three-tier architecture commonly used in web application. Web interface of the user is students and faculty or admin interact with the system through a user-friendly web interface. This is the front-end interface that displays information and collects input. Application layer of the backend logic is contains the business logic of the system. Processes user request, enforces rules, and handles interaction between the UI and the database. The database data layer is it stores all persistent data like student details, room assignments, etc. Optional add-ons, authentication for login and security. Cloud deployment is for hosting the application on cloud platforms like AWS, Azure, etc. Next is database schema, which is entity relationship diagram. This section shows how various entities in the database relate to one another, in which recipients hold users who receive feedback, attributes like PKID, name, etc. Next, feedback is main feedback data structure, which holds attributes like PK, question ID, feedback name, and question description. Next is feedback assignment, keeps the track of feedback task assigned. Attributes include PKID, FK, feedback ID, FK employee ID, results, submission date, etc. Feedback results. This stores the actual feedback responses. Attributes include results, anatomy, scores, comments, etc. average table, which is likely used to store computed average feedback scores. Submitters, who tracks who submitted feedback, contains PK employee ID, employee name, etc. Next is SQL queries for table creation, in which first is creating table students. Student underscore ID is a unique ID for each student, auto incremented. Name, email, phone, it is a basic contact details. Gender, it restricts values to male, female, or other. Preferences, students' room type choice. Roommate or preferences, optional stores another student's ID if they want a specific roommate. Password underscore hash, which includes securely stores the hashed password. Create table rooms, room ID, unique identifier for each room, block or floor, location details of the room, room underscore number, unique room number, room type means either single or shared, capacity, maximum number of occupants, current underscore occupants, tracks how many students are currently assigned, which is default is 0. Next is allocation ID, which is a unique record for each room assignment. Student ID, room ID, foreign keys linking to students and rooms. Allocation date, which is automatically captures the time the allocation is made. On delete cascade, deletes allocation if the student or room is deleted. Next is explained by Kavya.
Hello everyone, myself Kavya. Here I am to explain the concept of admin table. Store admin user information with unique admin underscore ID, name, email, admin identity, password underscore hash stores admin login password securely. Next one is request table, request underscore ID, unique request identifier, student underscore ID, refer to the student making the request, request underscore type, type of the request, example, change room or cancel, status, track request progress with the default as pending, request underscore date, captures the time the request was made. And next slide is implementation section. Student stores student information, room holds room details, room allocation keep track of which student is assigned to which room, admin store admin login details, request for handling special requests like room changes or cancellations, keys SQL features used, auto underscore increment, automatically increases the primary key value like student underscore ID, comma room underscore ID, foreign key ensures that relationship between tables example student must exist to allocate a room are consistent. Enum used to restrict value for field like gender or room underscore type. Example only male or female or others. Timestamp automatically record when certain events like room allocation or request submission happen. The SQL query retrieves the name of the student, the room number and the block they are assigned to. It uses joins to combine data from three tables, student, room allocation and rooms. Testing section. Purpose of testing section. Room allocation. A student select a room from available option. If everything is valid, the system should confirm the allocation with a room allocated successfully. Messages both expected and actual outputs matches so this features works correctly. Invalid room selection. A student tries to choose a room that is already full. The student correctly identifies this and shows an error message preventing the allocation. This shows that the system enforces room capacity constraints. Admin login. An admin provides correct login. The system verifies them and redirect the admin to the dashboard. Since both expected and actual behavior match, login works fine for valid users. Invalid login. Someone enters the wrong password or the system responds with invalid, indicating a security check in the place. This confirm authentication is working as intended. Room change request. A student requests to change their rooms. The system accepts the request and returns a confirmation message. Request submitted. This shows the request feature works. The works is being recorded properly. Next slide will be explained by Kumar.
Results of a hostel room allocation system. Efficient of a room allocation. Automated assignments are based on the performance and the availabilities, and it is good for the students to has an allocation the system of results. Improving admins of management. Centralized the database on the tracking of the students and the rooms. Error reductions. Validation of a prevently overbooking of students room allocations and the fast processing room changes, requesting the handling of simulations and the better transparencies, and the students as an admin can track allocation in real time. Conclusions. Automate the hostel management, reducing the manual work in the normal allocations, enhance efficiency, quick students has been to the request, and the transparent is the pair and the originalized body or the assignments. Challenge faced. Handling the room performance and the difficulty to the allocation the room as per as performance. Database optimizations. Management the large data efficiency. Future scope. AI based on the room as a smart allocations of using AI systems, and the mobile app integrations as an easier to the students to the succeed to the payments has been directly, and the online payment has been system hostel fees management. Thank you.
This is the front end code.